Hello, this is the second part, version tape B, and it's about indirect reasoning for section 5.6. And this is a form of reasoning that we use often. At first, I assumed that we are having hamburgers because today is Tuesday, and Tuesday is usually hamburger day. So we're identifying something. There's always ketchup on the table when we have hamburgers, so I looked for the ketchup, but didn't see any. Therefore, you're going to make an assumption that today hamburgers must be false. Today is not hamburger day, thus it's not Tuesday. And this is called indirect reasoning. First thing we do is identify the statement you want to prove, and assume temporarily that this statement is false by assuming the opposite is true. And there's the key. Assume the opposite is true, and then reason logically until you reach a contradiction, meaning you've proved that true statement to be false, and then point out the desired conclusion must be true because the contradiction proves temporary assumption false. So we take something that we know is false and say that doesn't work, there's a contradiction, and reprove it. Okay, let's go ahead and look at another example here. Next page. Oh, not that one. This one. If x is an odd number, then 2x is not an odd number. That's the conclusion. So the first, we'll identify the statement. Assume temporarily that the statement is false by assuming the opposite is true. The opposite, that 2x is x is an odd number, then 2x is an even number. So 2x is an odd number. That's what we're going to temporarily assume because it says up here 2x is an odd number, right up here. And the contradiction odd are not divisible by 2. And if it's odd, but 2x is divisible by 2 because we can go 2x divisible by 2, which gives us x. That is divisible by 2. So 2x is not odd. Since my assumption is false, that 2x must not be an odd number. Conclusion. Assumption is false. We can assume. We assumed it was an odd number, but we have to assume. The assumption is false. The assumption was what? 2x is not. The assumption is false. 2x must not be an odd number. So that was an indirect proof proving that 2x must be an even number. Let's go ahead and pause that. Okay, we have write an indirect proof of the corollary of the triangle sum theorem. Oh, we know the sum of the interior angles of a triangle equal 180, that the acute angles, that's these two angles are complementary, which means they sum to 90 degrees. So we're going to temporarily assume that a measure of angle 1 plus a measure of angle 2 is not, we're going to assume the opposite, not 90 degrees. So now let's see if there's a contradiction there. See if we can write something that'll give us a contradiction there. Well, we know that a measure of angle C plus measure of angle 1 plus the measure of angle 2 for any triangle equal 180. We know that. And since it says angle C is a right angle, that is 90 degrees. So we can stick 90 degrees in there for angle C. And if we subtract 90, we get measure of angle 1 plus measure of angle 2 is equal to 90, which is a contradiction because we assumed it was not equal to that. Thus, we can conclude. So as I was going to say, we're going to conclude that our temporary assumption, which is up here, is false. Thus, measure of angle 1 plus measure of angle 2 equals 90 and is complementary, which is what we set out to prove. Hey, have a wonderful day.